Hi again. Let's have the Newsvendor model in Excel. So again, at first, as you see here, we have the data of the problem. So the distribution for having the type of the day, it could be good, fair, or poor. So we have the probabilities here. We have the CDF again, and also we have the distribution for the demand for each day under having the type of the day, so the probabilities and the large fs or the cdf. So we have all this data here. Okay, and okay, so here as I said, for q, the q here is our decision variable, right? In an optimization model that we can develop for this problem, the decision variable would be obtaining the size of the order, right, the q. But here we are going to optimize this key by a simulation model, right? In order to do that, at any run, we need to consider a value for the Q. Okay, so here, for example, we assume that the Q is 50. So by having this value for Q, we simulate the system, and then we will have the performance result here. It's the average profit, for example. Okay, and we have this, let's say, for a run, which is $108.30. Okay, and then we can try different values for Q. That's for 50. We can try this for 60, 70, 80, 90, and we'll see which one actually generates higher profit in average. And then that will be our choice for considering as the order size. Okay, so again, here we are going to simulate the system for 20 days. So we have 20 rows here, and each row is for a day. And at first, we need to obtain the type of the day. What kind of day is going to be this day? And this can be done by having a random variable from the types of the day. So we have a discrete distribution for the type of the day. And yeah, here we are using the discrete empirical distribution in Excel by having that Visual Basic file, as I explained in the previous file. Okay, so yeah, and after having the type of the day, again, now we have a discrete distribution for the demand of that day, and we can again generate a random variable from that distribution in order to be the demand of this day. Okay, and after having the demand, now we know what the quantity is. It's 50. Now here demand is 70. So since demand is greater than Q, so the total sales will be the Q, right? It will be 50. And here we just multiplied 50 cents 0.5 by the total sale. It will be our total revenue. And here is our total cost and lost profit here. Since demand is greater than Q, so we have a lost sale, right? So we'll have lost profit. So here again, we can calculate the lost profit. I mean, all the equations here, formula for calculating lost profit on other columns, they are exactly the ones that we have in lecture notes. Okay, so you can refer these formulas to the lecture note and see what are the equations. We just implemented those equations here. And in this column, we can calculate the salvage value and at the end, the daily profit. Okay, and by having 20 days, then we can take the average on the daily profit, and that average will come here in order to be the average daily profit. Okay, and again, we can refresh the sheet and see by having any run, we see actually change in the results. That was 108 in previous run. Now it's 97. I mean, the average profit. Now again, 99, 114. So as you see here, results are not stable, and we can't rely on the results and make an insight, right? So in order to stabilize the results, we can do replication. So here we can replicate that simulation for 500 times. Yeah, and then have the performance measures: profit, revenue, cost, lost profit, and the salvage value. But as I said, the final measure here will be just the profit, right? And as you see here, the average profit is 104, and if we run replications, it's changed to 104.37. Again, one more time. It's replicating over and over. So I don't know why, but I think there's an issue with my laptop maybe. Okay, yeah, this is how we replicate the simulation runs in Excel and have more reliable results. Okay, so my Excel has freezed. Okay, now it's good. Okay, so yeah, this is how we implemented the simulation model of the Newsvendor problem in Excel. Okay, and now if we change the Q from 50, let's say, to 60, we will have other results, right? Let's try this 60. Now I refresh the sheet. As you see here, the profit becomes higher, 137, right? 151. And again, we can try 70. By doing these experiments at the end, we can come up with an idea that which Q has higher average profit after having 500 applications, and that will be our choice for the order quantity. Okay, and this is how we do this. Okay, so let's go for the next model. Okay, thank you.